quick introduction before I start my presentation. My name is Crispin Clark, and I work for a Canadian technology company. We're based in Kanata, which is in Ottawa in Canada, but we have operations around the world, and we have a sizable presence in Europe, especially in Germany. What I want to talk about this afternoon, and it's a very short time to present, so it's going to be kind of high level and summary information. But essentially, obviously, what we see and is generally known in the marketplace is there's a dramatic change happening in the automobile industry. Of particular interest to Solis and myself is what's happening in the technology. So obviously some of the trends, I think probably a lot of the people in the room already know this, but just to kind of summarize, there's a lot of new innovation in technology affecting everything from autonomous cars through to new manufacturing processes with 3D printing. A lot of new types of data for things like analytical data that's being gathered by OEMs and partners. And lastly, there's lots of new service models happening. The one that I want to spend the next 15-20 minutes to talk about is what's happening in connectivity services, and that's where Solis plays in terms of providing a solution. So if you read the industry reports, whether KPMG or McKinsey, what is believed is that there's a $1.5 trillion business that is going to be won by somebody in the car connectivity domain. So essentially, it's, again, widely known, but connectivity does change everything. And you can see on the slide here some of the leading players in this marketplace. So what is changing? What is car connectivity? Why is this so important to OEMs and other participants in the industry? Well, firstly, I think it's well known that if you're buying a car today, you're probably not going to buy a car that doesn't have connectivity services. So it varies around the world. If you look at, again, some of the industry reports, if you look in places like in Asia, it's a key decision-making criteria for buying a new car, whether it has connectivity services. That's obviously very important. I think the second thing is why connected car changes everything. It's because there's a dramatic new revenue opportunity available to OEMs or partners, existing companies that are in this space. Again, if you look at kind of the total spend of a car, the base prices are staying stable or going down. Where there's money, where there's revenue available is in the area of connectivity services. That's why it's dramatically important. Obviously, the third thing is as we move to autonomous vehicles. What are we going to be doing in our cars when the car's driving itself? So it's this concept of available time to provide services to people. We spend a lot of time in cars. The car's operating itself. What are we going to do with that time? So filling that time, whether it's office automation or infotainment or whatever it is going to be a critical thing moving ahead. So what does this mean from a technology point of view? If we can kind of just move away from the business, and what does it mean from a technology point of view? Well, if you look at a car these days, like an average prestige car, there's the computing power of like 20 to 30 high-performance PCs. There's an average of 100 million lines of code in a car. That's a lot of computing power that's a lot of data that's being crunched by that one vehicle. So then cars are, putting more and more sensors into cars. What does this mean? It basically means there's a deluge of data that is coming from the car, and that needs to be managed. It needs to be handled. It needs to be shaped. There's all sorts of ways of doing that I'm going to get into the next slides. But effectively, if you think about the problem, like terabytes of data coming off a car in 1 hour, and you scale that up to 5 million, 10 million cars, that's a significant amount of data that's coming off. If you kind of look at the traditional kind of big data charts that people publish, you see kind of nice smooth, and then there's this massive uptick of data. It's happened in other industries, and now it's going to happen in the automobile industry. So the other thing is there's all this data, kind of raw data, right? Sensor data, and how do you analyze that data? What are the tools you're going to use? Because really it's the insight into the data where you can make new revenue opportunities. So it's kind of how do you access that data? How do you move the data? How do you provide the tools to analyze the data? And then we have to remember that connected car is not just data flowing from the cars into an OEM or a third-party provider. There's data going back to the cars as well. So it's this idea of command and control of the car, which is a big problem to solve, right? If you have a typical implementation of maybe 3 to 5 million cars connected, well, how do you address that one car? So if I'm on my smartphone and I say, open the door on the car, you're going to make sure that you open the right car door. And it sounds like a simple problem to solve, but actually that's quite difficult to do from a technology point of view. The other key piece here is, if you again look at the analyst report and kind of what we've heard is obviously the security of the data is absolutely critical. People are worried about OEMs, everyone, like they're worried about cybersecurity. Could people hack into the system? And then from a personal point of view, people are worried about their personal data, right? Well, I don't want a company tracking where I've been or what I'm doing. So again, it's very important that this infrastructure provides a very strong and secure security mechanism to make sure that we're all safe. So kind of just going down another layer of detail, again, kind of moving away from the business to more to the technology, and kind of another layer of what this would look like and what really is happening here. So if you think about the cars, or the sensors in the cars, the computing power in the cars, creating this deluge of data. Part of the problem is cars are, we use our cars maybe 4 hours a day on average, right? So you started in the morning, leave the home at 7, maybe you get to the office at 8 or 9, and at the end of the day you drive home. So the data deluge is not just a constant stream of data, it's very spiky. So if you think about 2 million cars being started between 7 and 9, so you have this massive peak of data in the morning and then the same in the afternoon. So this technology has to handle that, right? We can't have a delay in the data. Like maybe there's some very important data there that needs to be sent to the car. So this technology behind this connectivity, and say connectivity off the scale, is providing this ability to cache data or store it to make sure that when the bandwidth is available, the data is moved. Or you can handle very seamlessly these big spikes of data. So what does that mean? It basically means kind of scaling up the number of connections you can have. So all the cars can connect in the morning, and then when the cars where they're all parked, you scale back on the connectivity layer. So, kind of from an architecture point of view, the way you solve this problem is you have kind of a scalable front end, and then, the data is then fed into the back end. So queuing of data is also important, right? Maybe there's some very important data that's coming from a data center. Maybe it's a map update or maybe it's a software update to the car. So that data's being queued. Maybe the car's off, maybe the car's in a tunnel. As soon as that car connects to the infrastructure, you want this magical data movement layer to move to queue that data and send it to the car. Again, kind of sounds simple if you think, like a small number of cars, but you scale that up over millions of cars. This is a big problem that needs to be solved. Car connectivity is obviously not just a European thing. It's happening around the world. So the other side of this is providing the infrastructure, again, to provide this sort of connectivity, caching, queuing of data, whether you're in China or Korea or North America or in Europe. So you need to have this consistent infrastructure. Maybe there's a data center in Europe that all the data comes back to. So maybe it's an OEM based in Germany that they want to get all the maintenance data, for example, from the cars in China. Well, that creates all sorts of problems from a network point of view, from a data ownership point of view, from a latency, or from a queuing point of view. So this smart connectivity layer has to handle all these types of interactions. So the last thing is the data. Where does the business, where does the revenue come from? It's not really the raw data, right? That data needs to be crunched, it needs to be analyzed. So you've got to provide the ability for this data to be fed into a data lake or some sort of analytical system. Again, that's a big problem to solve, where these analytical systems can only accept data at a certain rate. So the data has to be queued into them. Some insight is created in the data, and then it's sent back to the car, or it's sent back to the car owner's mobile phone. So for example, one of our customers is using this technology for maintenance, right? So it's been proven that if you send a message to a car owner's smartphone to say, hey, there's something going wrong with your engine, take it to our local dealership. Most car users will follow that instruction. So if you think about finding that one issue in that one car over a big data set, so you're kind of mining that data, you're finding that business opportunity and then sending it to the owner. There's a lot of number crunching, and there's a lot of this data movement that has to happen. So just to summarize, it's very important that this data is in the right format or can be changed into the right format so it can be run through these analytical systems. So who's going to win? Who's going to lose this? This race to this tremendous market opportunity, right? Again, PwC saying there's a $120 billion business in this area of connected car. Obviously, connected car, there's a vast range of services there. I'm talking about just kind of one subset of it's really kind of the telematics data, the proprietary data that the OEMs could keep and make money of. Obviously, there's a whole bunch of other types of connected car initiatives, from autonomous driving, from music and infotainment, and then kind of linking into like a work office environment. But essentially, there's going to be a lot of innovation. There's going to be a lot of new players moving into this space, existing players building solutions in this space. So to me, it's tremendous opportunity and tremendous challenges that need to be solved here. who's going to be the most successful in this business? You know, from my experience in other industries, it's the idea that, you know, and people kind of say, well, Apple do this extremely well, right? They provide a platform. So it's this idea of business agility. If you can roll out new services quickly, then that gives you a big competitive advantage, right? So I think this is where we see kind of a race to the OEMs improving their ability to design and build and roll out software. You know, other players kind of entering this space with a very, you know, kind of a technology-led platform, and we don't know what the revenue opportunities are 2 years, 3 years from now, but if you have the most agile platform, then you can move into those opportunities very quickly when they become apparent. So that's a quick 20 minutes or 17 minutes on, you know, this idea of connectivity at scale and why it's so important. And just to summarize, point number one is it's a tremendous change for the automobile industry, you know, that connected car is going to bring tremendous opportunities in there as well. Everything from, you know, influencing new buyers to looking at connected car services to, you know, after sale opportunities as well with things like, you know, maintenance, etc. Data challenges, you know, again, I've highlighted this, and volumes. You know, we as a company work in many different industries, financial services, government. The amount of data that we see in the connected car arena is a tremendous amount compared with some of these other industries. So kind of embracing that, and it's going to, you know, the deluge is going to get worse, like autonomous driving, obviously, and real-time updates. It's going to drive even more, you know, sizable volume of data. The next few leaders, question mark. I think that's the, you know, who's going to win? Like, we don't know. We'll find out in the next 5 to 10 years who's going to win on this side. But what we believe is the company with the best data management strategy, and, you know, data management encompasses like who owns the data, how do you manage the data in connected car, securing the data, how you analyze the data, how you look for insights, kind of that whole thing is encompassed in that one bullet. Whoever can do that the best is going to be, it has a good chance of winning in the space. And then lastly, the most agile to capitalize on change. You know, it's kind of well known in the technology industry that kind of a platform, the ability to change and roll out new services quickly gives a company a tremendous advantage over its competitors to win in this space. So at that point, I will stop. So thank you very much for your attention. I believe we'll have a little bit of time for questions. If you have any questions afterwards, I'd love to speak with as many people as possible. We have a small booth just outside the hall here, so happy to answer any questions now or afterwards.
Okay.
One question.
Becker, I am with the press, and there's something that is missing in the whole conference, where we talk about either software or hardware that we're going to implant into the vehicles, future vehicles. There's no cost figures about all the transition that we are going to go through. To build an automobile, the cost will be as it was in the past. To complement it with some connection and electronics and whatever will increase the price. On the other hand, if we develop systems that are, let's say, public transport, like an autonomous taxi, and connected with BRT, which will be autonomous.
Yes.
All of this will reduce the amount of vehicles we are going to sell for private use.
Yes.
So the question is, if on the one hand the cost of the vehicle will increase, and on the other hand the sales will decrease, how can you implement all the information ideas, everything there, when you have a poor economic balance?
I think that's a very good point. I think, kind of you brought up lots of different ideas there, and my take on it would be that the OEMs, the providers in this industry, have to provide a transportation service. So whether that's your own car or a shared car or autonomous car or a bus or whatever, I, as a person, I want to go from point A to B. So I think one of the winners will be that company that provides that service to you, right? However you want to do it. Maybe you want a low-cost model, so it's a shared service. Maybe you don't have a low-cost, you want a different type of service. I don't know if that answers your question. So it's the economics are, in my mind, they're absolutely there. Someone's going to provide this type of service. From kind of the other aspect of your question was kind of hardware versus software. And what goes into one of these platforms. In our mind, Solus, we build both hardware and software. There's some kind of in the middle of these architectures where all the data is. Software can't solve that problem. We need custom-built appliances, we call them, that can handle the amount of traffic that's kind of in the core of these networks. We're talking like 10 million messages per second that this thing can handle. So I think that's kind of the other side of your question, that there is a point where economically software doesn't work in those, you have to have another type of platform that offers this very high performance.